Welcome back. We are going to finish up our point 4 today on factoring polynomials. Today we're going to work on binomials, very specifically 3 special cases. So we have difference of squares, difference of cubes, and sum of cubes. If you have a difference of perfect squares, that looks like this. When we factor it, we square root each term. Write each term down. One's plus, one's minus. And it doesn't matter which one is plus and which one is minus. For the sum and difference of cubes formula, it's very important that you follow the formula and follow the signs given in the formula. Okay, you have to follow the signs given in the formula. The only time you use the signs that are given to you here are to determine which formula you use. If you have a difference of cubes, your first term will be subtraction. And if you have a sum of cubes, your first term will be addition. You're taking the cube root, and the formula will be x minus y, x squared, plus xy, plus y squared. X plus y, x squared minus xy plus y squared. Okay, you have to follow the signs in the formula, not the sign given when you're multiplying and doing all that stuff for the formula. There is no factoring pattern for a sum of squares in the real number system. All right. So that would be, for example, if you had 4a squared plus 9. Okay, 4a squared is a perfect square, plus 9 is a perfect square. But if I took the square roots, I would get 2a and 3. And the only way to make this a positive would be if these were both minus or they were both plus. Well, if I were to FOIL that out or distribute or whatever to check my work, 2a times 2a is 4a squared. 2a times negative 3 is negative 6a. Negative 3 times 2a is negative 6a. And negative 3 times negative 3 is positive 9. Well, look in the middle here. Negative 6a minus another 6a is negative 12a. And so we end up with a middle term. There is no possible way, unless we start talking about imaginary numbers, for us to factor a sum of squares. So let's try some of these. Difference of squares. We have subtraction, 2 terms. That's the very first thing you're going to check. Subtraction, 2 terms. If that checks out, then we try taking the square root of them. The square root of 4 is 2. The square root of m squared is m. The square root of 9 is 3. So we write that twice. One's plus, one's minus. Doesn't matter which is plus, doesn't matter which is minus. 2 terms, subtraction, perfect. Square root them. The square root of 256 is 16. The square root of k to the 4th means you take half of the 4, which is 2. All right, the square root of 625 is 25. And the square root of m to the 4th, or half of 4m's, is 2m's. So we write that twice. One's plus, one's minus. And that's our factored form. All right, well, we have technically this parentheses is one term. 4c squared is the second term. We have subtraction in between them, so this technically would be a difference of squares. Square root, remember we don't have the minus underneath the radical. We don't have i's here. The square root and the square erase each other out. So we have a plus 2b as that first term. And then the square root of 4c squared is 2c. One's plus, one's minus. Well, this wouldn't be college algebra if we didn't throw in some interesting parts. And that's going to be this right here. Let's factor that x squared minus 6x plus 9. The x squared minus 6x plus 9, if we factor it, we need the factors. This is 1 times 9. So the factors of positive 9 that add to negative 6, which are going to be negative 3 and negative 3. So we have x squared minus 3x plus 9. Splitting it down the middle, GCF on the left is x, leaving us with x minus 3. The right side starts with a negative. The GCF of 3x and 9 is 3. That leaves us with positive x minus 3. So our new GCF is x minus 3. And when we pull those out, we're left with another x minus 3. So this side right here is technically x minus 3 squared. And then we have a minus y to the 4th. Well, this is just like C now, where we have a square, perfect square, two terms, subtraction. So we can square root each term. The square and the square root reduce each other out. So we have x minus 3. And the square root of y to the 4th is y squared. And then x minus 3 and y squared. One's plus, one's minus. And this would be factored form. For letter E, this one gets even goofier. So we want to separate that x squared plus 6x minus 9 out. But remember, there's a negative in front of it. So when I pull that negative out, technically I'm pulling that negative out. Now, rather than a negative, it's a positive x squared. Rather than a positive 6x, it's a negative 6x, and then a positive 9. Because again, we separated that negative out from that set. Well, we already did the factoring for this over in letter D. So we know this is y squared minus x minus 3 squared. Two terms, subtraction. Take the square root of each. The square root of y squared is y. The square root of x minus 3 squared, remember these undo each other. And y and x minus 3. One's plus, one's minus. And so that would be factored form. Lots of fun in there. Sum and difference of cubes. So remember, you have to follow the signs in the formula. The only thing that we're looking at in terms of the signs given to us is which formula to use. So this is the sum formula. And the first thing that I need to do is I need to take the cube root of each one. Now in your calculator, you can find the cube root by doing 27 to the 1/3 power if you weren't sure what the cube root of 27 was. And the cube root of x to the 3rd is x. So we have x, and we have 3. So plugging it into our formula, we have x plus 3, and again, we're using sum of cubes because the plus is given to us. X squared minus 3 times x is 3x plus 3 squared. 3 squared is 9. And that is our answer. This second part, the trinomial, should never be factorable. Okay, that second part should never be factorable. If it is, we need to go back. All right, letter B. Letter B is a difference because of the subtraction. So we're following the difference formula. I'm going to change to green. We're taking the cube root of all of this stuff. So the cube root of m cubed is m. We're using the subtraction for our first parenthesis. The cube root of 64, remember you can do 64 to the 1 divided by 3 power, is 4. And the cube root of n cubed is n. That's our first parenthesis. So now we square the m. That's m squared plus m times 4n is 4mn plus 4n squared. So 4 squared is 16, n squared is n squared. And this is factored form. Letter C. The plus sign here tells us that this is a sum of cubes formula. So we're going to take the cube root of each. The third root of 8 is 2. And remember, we take the 6 and we divide it by the 3 because we now know how many sets of 3 can we get into 6. And that's q squared. Bring down the plus. The cube root of 125 is 5. The cube root of p to the 9th is 3 because 3 times 3 makes 9. And so that's the first part. Now our second part. Please be careful in here. We're squaring 2q squared. So 2 squared is 4. Q squared, remember we multiply those together, is q to the 4th. Minus is in the formula. And we multiply these two parts together. So 2 times 5 is 10. Q squared p cubed. Plus 5p cubed squared. 5 squared is 25. P cubed squared means I do 3 times 2, which is p to the 6th. And so this is our factored form. Last but not least is factoring by substitution. So basically what we're doing is we are pulling out something that makes it awkward for us to factor and setting it to some random number where we can go back and plug in the value that made it awkward. And usually we use u. And it's usually going to be whatever value is in parentheses. Oops. Usually. So I'm going to start with A. And we have this 2a minus 1 That is really making it awkward for us. So I'm going to change that 2a minus 1 and replace it with u. If I do that, that's 10u squared, because there's a square out there, minus 19u minus 15. Now I can factor this. 10, 19, and 15 do not have any common terms. So I'm going to do 10 times negative 15 is negative 150. I need two values that multiply to negative 150 and add to negative 19. Now remember, you can go into your graphing calculator. Y1 is equal to negative 150 divided by x. Hit that table and start looking at those whole numbers. And when we do, we see that we get negative 25 times positive 6. Negative 25 times positive 6 is negative 150. Negative 25 plus 6 is negative 19. So 10u squared, this is u, so minus 25u. That's a positive 6, so plus 6u. Bring down the negative 15. Split that in half. Our GCF on the left side is going to be 5u. Leaves us with 2u minus 5. Plus, common factor on the right side is 3. Leaves us with 2u minus 5. This makes our new GCF 2u minus 5. So we have 2u minus 5. And then the leftovers are 5u plus 3. Well, we're not finished yet because this is not what we factored. There was no u in the original part. So we need to go back and replace the u with the 2a minus 1 that was there to start with. And now we need to simplify these. So we'll distribute and combine like terms. Oops. And then distribute here. Oops, 5 times 2 is 10. A minus 5 plus 3. Like terms here are 10a minus 2. Well, I notice that this one has a GCF of 2 still. So we need to pull that out because remember, our final answer should have no common factors in the parentheses. So we're pulling out a 2, and we have 5a minus 1, and then we have the 4a minus 7. And so this is the answer of letter A, factored. Letter B. This 3 right here with basically 2 terms and 8 says this is probably going to be a sum, and I say sum because of the plus sign, sum of cubes formula. But again, that 2a minus 1 is making it awkward for us to be able to solve this. So I'm going to say, okay, hey, let's pull that 2a minus 1 out and make that u cubed plus 8. Wonderful. Well, now I know what to do because I can take this and do the third root, u plus 2. Square u is u squared minus 2 times u is 2u plus 2 squared is 4. So this is factored form. But remember, our original problem had A, not U. So we go back in and say, all right, this U is really 2A minus 1 plus 2. And then we got to come in here and do the same thing. 2A minus 1 squared minus 2 times 2A minus 1 plus 4. Well, I have to do all of this math. Starting over here on the left, I have nothing here that changes for me to distribute. So I can drop the parentheses and then add like terms. Negative 1 plus 2 is 2A plus 1. On the right side, well, I need to start with 2A minus 1 squared. Well, remember, 2A minus 1 squared, we cannot distribute. That's 2A minus 1 times 2A minus 1. FOIL, distribute, Punnett square method, however it is that you love to multiply. 2A times 2A is 4A squared. 2A times negative 1 is negative 2A. Negative 1 times 2A is negative 2A. And negative 1 times negative 1 is positive 1. These are my like terms. And so I would have 4A squared minus 4A plus 1. Distribute minus 4A plus 2. And then we have that plus 4 hanging out there. Combining like terms in here gives us finally a lead to our final answer. We have 2A plus 1 there. And then over on this side, we have 4A squared. Negative 4A minus 4 more A's is negative 8A. 1 plus 2 is 3 plus 4 is 7. And that will be the answer. Letter C. We don't have to use substitution for letter C. We can, but I like just using regular old factoring here, and I'll show you why. So let's start with common factors. 6, 13, and 5 have no common factors. So we're going to go ahead and do 6 times negative 5 is negative 30. The factors of negative 30 that add to negative 13 are going to be 2 and negative 15. So bring down the 6z to the 4th. Now remember when we talked earlier, we said whatever is here is what goes with these two terms, and that's a z squared. That's a positive 2, so plus 2z squared. That's a negative 15, so negative 15z squared. And then bring down that minus 5. Now we can split this in half. GCF over here on the left is 2z squared, leaving us with 3z squared plus 1. On the right side, it starts with subtraction. Common factor here is 5. Negative 15z squared divided by negative 5 is positive 3z squared. Negative 5 divided by negative 5 is positive 1. Well, now our new GCF is 3z squared plus 1. And our leftovers then are going to be 2z squared minus 5. All right, that's it. Please make sure you bring your questions with you. Have a fantastic rest of your day.